Hi there! In the following video I will show you how to answer the Unit 3 Higher AQA Maths Practice Paper 1. Do remember, as always, this is a calculator paper and it's an hour and 30 minutes long. Furthermore, there is a formula sheet at the front of the exam booklet that tells you certain areas and volume formulae, and it tells you area of a triangle, sine and cosine rule, and the quadratic equation. Let's start straight away. Question 1. S and T are shapes drawn on the grid. Here's S and T. They're both trapezia. That's because they have one pair of parallel sides, sorry. In fact, they're isosceles trapezia because this side and this side are the same length. Draw the reflection of T in the line x is 1. X is 1 is where all the x coordinates are 1. Anything there that has an x coordinate 1. So the first thing you should do is draw the line x equals 1 as such, label it, the line x equals 1, and you want to draw the shape T reflected. So pick a corner. This is 1 away from the line of reflection, so this one will be 1 this side of the line of reflection. This is 2 away, so this will be 2 away, and so on. This here is 1, 2, 3, 4, 5 away, so 1, 2, 3, 4, 5. And similarly, this is 1, 2, 3, 4 away, 1, 2, 3, 4 away, as so. And there is our reflected shape, which you should fill in with a pencil and ruler. Just fill it in neatly like as so, and that is the reflection in the line x equals 1. Now describe fully the single transformation that maps T onto the shape S. Okay, so imagine we wanted to map T so that it went on to S. Now, just looking at it, it's no sort of reflection that gets you there. It's no translation because the shape has been turned around, and it's no enlargement. So it's got to be a rotation. And what you need to do is, with a piece of tracing paper, you would put the tracing paper over the shape T, trace it out, and then try holding your pencil down at various center of enlargements. What end up working for you is actually the center of enlargement 0, 0. Always a good one to try 0, 0. If we were to have a piece of tracing paper over T, draw T in, hold our pencil down here, and we would have to rotate it 2 half turns, so it would be 180 degrees. Now, clockwise or anti-clockwise doesn't matter because 180 degrees either way gets you the same place. So to describe the transformation, you've got to say the word, it's a rotation, and next you've got to say by how many degrees. So it's 180 degrees, and finally you've got to say what the center of rotation is. So the center is 0, 0. Question 2. The straight line AB has angles 2x, x plus 10 and x minus 30. Set up, you must set up and solve an equation to find the value of x. Angles in a straight line add to 180, so I can say that 2x plus x plus 10 plus x minus 30 must add up to give me 180 degrees. Now all I have to do is collect like terms. 2x plus x plus x gives me a total of 4x's, and 10 plus minus 30 is the same as 10 minus 30, which is minus 20, and I get 180 for that. Now I have to solve for x, so add 20 to both sides of the equation. 4x must equal 200, and then divide both sides of the equation by 5, by 4 even, to get what 1x is, and you would get x is equal to 50 degrees. So 50 degrees is our answer to this one. Okay, question 3. The perimeter of the square is equal to the perimeter of the rectangle. The area of the square is 144, and the length of the rectangle is 4 times the width. So if the width there is x, and that one would have to be x, This one, the length, the longer one, is 4 times that, so it would be 4x, so this one would also be 4x. Now, the area of the square is 144. To work out one of the sides, because the sides are the same, one of the sides must be the square root of 144, which is 12 centimeters. So you know that this side here must be 12, this one is 12, similarly this one is 12, and this one is 12. So clearly the perimeter of the square must be 4 lots of 12, which is 48 centimeters. Now you know that the perimeter of the square is the same as that of the rectangle. Well, what's an expression for the perimeter of the rectangle? X plus x is 2x, plus another 4x is 6x, plus another 4x is 10x. So 10x's must equal the same distance of 48 centimeters. So what's 1x? X in particular must be 48 divided by 10, which is equal to 4.8 centimeters. And hence the answer again is the width is 4.8 centimeters. Question 4. The diagram shows two rods placed end to end. This rod has length 5x plus 3. This rod has length x plus 11. Work out an expression for the total length of the two rods in terms of x. So if I want to find out the total length of the two rods, I just add these two expressions together. So I take 5x plus 3 and I add on to it x plus 11 and I collect like terms and tidy up. So 5x plus an x is 6x and 3 plus 11 is simply 14. So an expression for the length of the two rods together is 6x plus 14. B. We've got three different rods here with length 3y minus 2, 2x and y. And we're told that that is the same length as the two rods that we considered in 4 part A. Now remember in 4 part A we said that the combined expression for these would be 6x plus 14 for their length. Now what is the length of the three rods? Well, you've got 3y minus 2 plus 2x and plus a y. So collecting like terms, 3y plus y is 4y. I'm going to write the x's next. I've got plus 2x and I've got this number term minus 2. Okay, so that expression there is the length of the three rods. Now we know that two are the same, so we can write that 6x, actually I'll write it the other way around, we can write that 4y plus 2x minus 2 is equal to 6x plus 14, 6x plus 14. Now I want a formula for y in terms of x, so really I want to make y the subject. So I want to remove this plus 2x and remove this minus 2. So to both sides I'm going to subtract 2x and at the same time I'm going to add 2. That will remove the plus 2x here and the minus 2 here, and I'll just get a 4y. And over here, if I take away 2x, I'll get 4x, and if I add 2 here, I'll get plus 16. And to make y the subject, I should have y by itself, so I divide both sides by 4, and I would get y is equal to 4x divided by 4 is x, and 16 divided by 4 is 4. Hence your answer to 4b. A nice simple question 5, a translation question. You've got a triangle A shown here. Translate the triangle by vector minus 2, 3. Minus 2, 3 means move it 2 left and 3 up. So I pick a corner, and I move that 1, 2 left and 1, 2, 3 up. That corner moves there. You could move each of the corners the same way, but now I know how to fill in the shape. If that corner has turned to that corner, to fill in the shape, I simply go from here. I go 2 up, 1 across, and join the diagonal. And that is my new image after the translation. Okay, question 6. We've got two right-angled triangles, A and B. The area of triangle B is 50% greater than the area of triangle A. Work out the height here. So, I want to work this out here. Let's work out the area of triangle A. So, how do you work out the area of a triangle? Well, it's half the base times the perpendicular height. So the area is half the base, half times 8, times the perpendicular height, which is 5. And I get for that an area of 20 centimetres squared. Now it says that the area of B is 50% more than that of A. So 50% of A is 10, half of it is 10, so adding that on for a 50% increase, the area of B must be 30 centimetres. So the area must be 30 centimetres squared. I can also find that out by doing 20 multiplied by the decimal multiplied by 50% increase 1.50. So I know the area of B is 30. Well, what is the formula for the area of a triangle? It's half the base times the height. So I can use that to find h. So half the base, half times 10 times h, must give me this 30 that I found. Well, a half times 10 is 5. And 5 times h, a mathematician writes as 5h. So I know 5h is equal to 30. So solving for h, I divide both sides by 5, and I get h must equal 6 centimetres. Okay, the diagram shows parts of two regular polygons. A regular polygon is a straight-sided shape where all the sides are the same length. A has 12 sides and exterior angle 2x, and it's got 12 sides. B has exterior angle 3x. Work out the number of sides of regular polygon B. Well, I know that all the exterior angles outside a polygon add up to 360. And I know that there are 12 of them. There are 12 of these exterior angles in A. So from A, I can say that 360 divided by 12 must tell me the size of each of those angles, what they must be. And I get for that 30 degrees. But I know that each of those angles is given by the expression 2x. So I know that 2x must equal 30, and in particular, therefore x must be 15 degrees. So I know x is 15 degrees. So this is all to do with shape A. Let's move on to shape B. Well, the exterior angle, therefore, here must be 45 degrees because it's 3 lots of the x, 3 lots of 15. Now, to work out how many sides the shape has, we know that the exterior angles add up to 360. If I divide it by each angle, each one is 45 degrees, it will tell me how many sides there are. So 360 divided by 45 is 8. So shape B is a regular octagon. It has 8 sides. Okay, question 8. We've got a company that makes sheets of steel in the following shape. Here's a semicircle with a trapezium on the end. So we want to show that the total area is given by this. So it's quite nice of them to give us the actual number we're working towards. Let's split this up into two shapes. Let's call them A and B. A is a semicircle and B is a trapezium. Let's work out the area of A. Well, it's half a circle. So it's simply, the area of a circle is pi r squared, so the area of A must be a half times pi times r squared. Now careful, the diameter of this semicircle is 30, so the radius must be 15. So a half pi r squared would give me the area of A, so I work that out. And I get 353. 353.4 centimeters squared. And now I'm going to add on the trapezium B. Well, Well, the trapezium formula is given in our formula booklet. It's a half. You add up the parallel sides, so 30 plus 40, and then you multiply by how far they are apart, i.e. 20. And that should give me the area of B. And I get for that 700 centimeters squared. So the total area must be these two things added together, and I get myself 1053.4 centimeters squared. Now do remember they've asked for the answer to 3 significant figures. So the first significant figure is thousands, then hundreds, then tens. What's the nearest 10 to 1053.4? Well, it's 1050. So I would write that as 1050 centimeters squared, and I would just state that I've rounded that to 3 significant figures as required. Now it tells you that the steel costs 0.05 pence per millimeter squared, and the shapes are coated in zinc to prevent corrosion, and it costs 3 pence per shape. Work out the total cost of making 4,000 shapes. So the first thing is the corrosion cost, the zinc cost. So I'm going to just write the zinc cost. It's 3p per shape. So it's 0.03 in pounds times 4,000. And it's £120. So just the zinc coating costs £120. Now we've got to have how much the steel costs for the actual material. Well, it costs 0.05 pence per milliliter. So we're going to change that into pounds. This is how many pence it costs. I'm going to divide that by 100 to work out how many pounds that is, and I'm going to multiply it by the area of the shape, which I said was 1050. So I'm going to multiply that by 1050, and that will cost me 0.525 for each shape. And so for the 4,000 shapes, it's going to be 4,000 times 0.525, and it's 2,100. So we need to add together our zinc costs and our material costs, and therefore we get a total of 2,220. So in total, £2,220 for the cost of those 4,000 shapes. Question 9 has a cuboid in a grid, an x, y, z grid for us. Remember, when we're giving coordinates here, we give the x first, then the y, then the z, and it asks us for the coordinates of B, this point here. Well, B is in line with A in so far as the x coordinate. It's x down this way, so A is 2 along the x-axis, sorry, so B must be 2 as well. B is also in line with C, which is 3 along the y-axis, so B must be 3 along the y-axis. And also B, it's in line with A, C and O in terms of the z coordinate. It has no height, it's not up at all, it's flat in terms of the z, so it's 0 coordinate there. So the coordinate is 2, 3, 0. The coordinates of F, let's look at F here. Well, F, let's do what we can easily. F has the same y coordinate as C and B, so it has y coordinate of 3. In terms of its x coordinate, it's also 2 this way. It's in line with A and B again, so 2. But this time it has got some height. It's got the same height as coordinate D. It's in line with D, which has z coordinate 1, so it must have z coordinate 1 too. Okay, the next question, 9c, asks us to work out the length of DF. Let's just draw in where DF is. D to F. It wants that length there. So I'm just going to highlight that in another colour for us. It wants that length there. Now, do notice that we've got a right angle triangle on the top of this cuboid, and there would be the right angle. So if we knew this distance FG and that distance GD, we could work out the red line by using Pythagoras. Well, what is FG? Well, FG is the same length as BC. What's the distance between B and C? Well, B had coordinate 2, 3, 0, x coordinate, and C has coordinate 0, 3, 0. So the distance between these is 2. So that distance there is 2. The distance between these here, well, G is 3 along in terms of the y plane. It's 3 along here, and D is 0 along. So that distance must be 3. So we've got ourselves a right angle triangle that looks something like this, and we want to work out that distance. So if we want to work out df squared using Pythagoras is 2 squared plus 3 squared, and we get 13. So df must be that square rooted, so the square root of 13, and we get the answer 3.6. So 3.6 centimeters. Okay, question 10. 4 pumps usually empty water from a tank in 1 hour and 36 minutes. Let's just convert this all into minutes just to make things easier. That would be 96 minutes. Okay, so if we had 4 pumps, it would take us 96 minutes for all those pumps. So one of the pumps is going to break down. How long will the 3 pumps working at the same rate take to empty the tank? Now, just think about it. If 4 pumps are taking 96 minutes, then what would 1 pump take? Well, we're dividing the workload by 4 and we're getting 96 minutes. So if we only had one, one box is 96 minutes times 4. It would take 4 times longer if we only had one box. So 96 times 4 would give me 384 minutes. But they're saying we've got 3 boxes. So in fact, we've got 3 boxes. So we can divide this total time, this 384, divided by 3, because we're sharing that workload, divided by 3 now. So we would get, it would take 128 minutes. Which makes sense, because if we have less boxes, it's going to take longer. Now, we've got a money problem again. Azad spends €140.40 on fuel, and the fuel costs €1.30 per litre. So let's work out how many litres he must have used. So his litres, if he spent €140.40, and each one costs him £1.30, each litre costs him £1.30. If I divide the two, I get that I must have used 108 litres, so 108 litres. Now you will remember from a previous video, we need to know the following, that 1 gallon is approximately 4.5 litres. So that's something we're expected to have an awareness of. Now, how many gallons is this therefore equal to? Well, this must be equal to 108 divided by 4.5, which is 24 gallons. So it must be equal to 24 gallons. Now, he travelled 120 miles in France, and we want to work out his fuel economy. So we want to do the distance divided by the amount of fuels used, and we want it in miles per gallon. That's why I changed things into gallons. So the fuel economy is equal to the distance, 1,200, divided by how many gallons, which is 24. And the answer is 50. So the fuel economy is 50 miles per gallon. Question 12. Two overlapping squares of side x and x plus 1 are drawn inside square PQRS. PQRS, and we've got the square x by x and the square x plus 1 by x plus 1. Show that the area of the shaded section A is x squared minus 5x plus 6. Okay, well, firstly, let's discuss what the area of the whole shape needs to be. So the key point here is that the area of the overlapping square is 9. If this area is 9, this side must be 3, this side must be 3. And obviously, therefore, this side must be 3, and this side must be 3. Now, we want to work out the area of A. Now, we need to work out this height, or this length, times this width. So let's go for this height first. The total height of this square is x. And if we subtract the 3, we're left with what this is. So this here must be x minus 3. And to get this one here, this whole length is x plus 3. If we take away 3, well, x plus 1, this whole length, and then we take away 3, we simply get x minus 2. So this length here must be x minus 2. So the area of the rectangle A must be x minus 3 multiplied by x minus 2, and we can expand that out. X times x is x squared, x times minus 2 is minus 2x, minus 3 times x is minus 3x, and minus 3 times minus 2 is plus 6, and collecting like terms we get x squared minus 5x plus 6 as required. Question 13. The diagram shows the circle centre O and work out the value of x. Now you will remember one of your circle theorems, the angle subtended at the circumference of the circle is half the angle subtended by the same arc at the centre. So therefore x must be twice as big as the 47, must be 2 times 47, which is 94 degrees. Question 13b, PQRS is a cyclic quadrilateral. That means it's got 4 sides and each of the corners are on the circumference of a circle. Prove that PQ is parallel to SR. We want to prove that PQ is parallel to SR, even though they currently don't look like that at the moment. So to do this, just follow your nose, do something obvious. Use the obvious circle theorem about a cyclic quadrilateral. You know that opposite angles add to 180. So 7x minus 30 plus 3x plus 10 must add up to 180 degrees. 7x plus 3x is 10x, minus 30 plus 10 is minus 20, and you get 180 when you do that. So adding 20 to both sides, you get 10x must be 200, and dividing both sides by 10, you get x is equal to 20 degrees. So if x is 20 degrees, 3 times 20 is 60, plus 10 is 70. This one's 70. This one's 4 times 20, 80, plus 30 is 110. And this one is 7 times 20 is 140, minus 30 is 110 degrees. And clearly, again, this one must be 70 because angles in a quadrilateral add up to 100, opposite angles add up to 180. So how does this show that PQ is parallel to SR? Well, let me just imagine PQ was this line here and SR was this line here. And I'm going to draw them so they look a bit more parallel than they currently look in the picture. Okay, what we have shown we've actually shown is that that line cuts it and that line cuts it. We have shown that this angle here is 110 and this one's 70, so this one's 110, and this one here is 110, so this one given that that's 70, must be 110 as well. So we've got Z angles or alternate angles going on here. So because the angles are alternate, PQ is parallel to SR. Question 14, we've got ABC on the banks of a river. The width of the river is constant. Work out the distance AC. So we've got a triangle here. It's not a right angle because we've got 100 degrees in it, and we've got two of the sides. We're wanting to work out the distance AC, which is this one here. So we're going to think to ourselves, use the cosine rule, which is given to us in our formula booklet as the side you want to work out, A squared, is the other two sides squared, added together, minus 2 times the product of the other two sides, B times C, times cos, or cosine, of the angle in between the two sides you know, which I'm going to call cos capital A. So if I want to work out AC squared is going to be equal to 25 squared, one of the sides you know, plus 43 squared, minus 2 times 25 times 43, so 25, 43, and cos of the angle in between, so cos, and the angle in between these is 100. So if we work that out, we get something like 2,847. So AC is the square root of that, so I take square roots of 2,847, and I get the answer 53.3. And the unit is meters. Part B asks us to work out the width of the river. So we're wanting to work out, let's go back to our diagram, let's put in a line here. We're wanting to work out this distance here, the width of the river. Okay, well, what can we do to work out that width? Well, the key thing here is that the width of this river is constant. So rather than taking the river's width there, I can measure it at any point that's helpful to me. And that point there is going to be helpful to me. And the reason that is because this creates for us a triangle here, and it's a right angle triangle with a right angle there. So we've got ourselves a right angle triangle with hypotenuse 25, and we've got the inside angle here, which must be 80. Okay, so I'm going to draw that on the next page. We've got ourselves this following triangle here. It's a right angle triangle. We know there's 90 degrees. We know the hypotenuse is 25. So we know this distance here is 25 meters, and we know that angle there is 80. And we're wanting to work out the width, which in relation to this angle here is the opposite angle. So what formula links the opposite angle, the angle and the hypotenuse? Well, sine does. So we know that sine of the angle 80 must be equal to the opposite, which we don't know, divided by 25. So rearranging that, what is the opposite equal to? Well, I times by 25 is 25 times sine 80. And when you do that, you get the answer 24.6 meters. 24.6 meters. Okay, question 15. PQRS is a trapezium, and it tells us that SR is parallel to PQ. So SR is a multiple of A. The vector A gets you from P to Q, so SR must be some amounts of A because they're parallel. In fact, it tells us that SR is equal to 2PQ, so this distance here is twice that distance. Write down in terms of A and B the vector SR. Well, to get from P to Q is by vector A. So to get from S to R, given it's twice as big as PQ, must be 2 times vector A. 15b, work out in terms of A and B vector QR. So what is this vector here from Q to R? So the question is, how do I get from Q to R? Well, I could go a long way around. I could go back A, so I would go minus A to get to P. Then I would go back this, so I would go minus A and plus 2B. And then I would go along this here, which is 2A. So combine this, minus A plus 2A is just 0. So this would be equal to 2B. 16. Butter is sold in tubs. The tubs are similar in shape. Two shapes are similar if one is an enlargement of the other. So the small tub contains 250 grams. The dimensions of the catering tub are double those of the small tub. The small tub holds 250 grams of butter. How much does the large tub hold? Now, the dimensions are the lengths. So the lengths of the small tub, so I'm just going to take the small tub like this. The length of the small tub is half that of the bigger tub, or the bigger tub. If this is length x, then this the other one would have length 2x. So the scale factor to get you from the lengths is timesing by 2. Now, for a volume, if the lengths are getting times by 2, then the scale factor for the volumes is multiplying by 2 for one dimension, by 2 again for the next dimension for the width, and 2 again to get you volume. So you've got to times by 8. The scale factor for volume in this case would be 8. So if you know the small tub holds 250 grams, the large tub must hold 8 times that, which is 8 times 250, which is 2,000 grams. (16b) A large tub holds 500 grams of butter. The height of the 250 gram butter is 50. Work out the height of this one. Well, we know now that these are different shapes here. The scale factor of the volumes is 2, because that 250 times 2 would get me 500 grams. So the scale factor of the volumes is times 2. So the scale factor of the lengths must be the cube root of 2, because that's the number that when you multiply it by itself 3 times gets you 2. So that's the scale factor of the dimensions. So if I know that is height 50 milliliters, this height must be 50 times the cube root of 2. And that gets to 63 millimeters to the nearest millimeter. Okay, question 17. The graph of y equals cos x between 0 and 360 is shown. You should know these graphs. They go between 1 and minus 1. Draw the graph of the following, okay, using the graph y equals cos x to help you. So we're going to draw the graph of the following. Let's draw the graph of y equals 2 cos x. So here's the graph of y equals cos x. You could either know these by knowing your transformation rules, or I would suggest you on the day just work it out for various important values of x. Let's x is 0. Put 0 into this formula. Cos of 0 is 1. 2 times 1 is 2. So that has value 2. Let's go to 90. Cos of 90 is 0. So 2 times 0 is 0 again. Put in 180 in here. Cos of 180 is minus 1. 2 times minus 1 is minus 2. 270, you can see the pattern is looking like this. This graph here is just a stretch by scale factor 2 in the y direction. Again, you could realize this is a reflection in the line y equals 0, or you just work it out for various values. When x is 0, cos of 0 is 1, so minus of that would be minus 1. Cos of 90 is 0, so minus 0 is still the sign 0. Cos of 180 is minus 1, minus minus 1 is 1, and as you can see, this is just reflecting this shape here, so it looks something like this. This is a reflection in the line y equals 0, or in the x-axis. 17c, the graph is y equals 2 plus cos x. Again, you could know this by knowing your transformations. We'll just put important values of x in. Let's go for when x is 0, cos x is 1, so y must be 3 in that case. When x is 90, cos x is 0, so y must be 2 plus 0 is 2. When x is 180, cos x is minus 1, 2 plus minus 1 is 1. And you can see the pattern here, what's happening. I'm not going to go much further than this, but you can see it looks something like that. It's a shift up 2 units in the y direction. And lastly, sketch the graph of y equals 3 to the x. Label any points of intersection. You could know this. All graphs, anything to the x graphs always look like this, and they go through the coordinates 0, 1. But if you're not sure, you didn't remember that, you just plot various points. Choose x to be various things. Let's choose x to be minus 2, x is minus 1, x is 0, x is 1, x is 2, just to get us a starting point for this, and it will help us to see what's happening. 3 to the power of minus 2, you type it in your calculator, is a ninth. 3 to the power of minus 1 is a third. 3 to the power of 0, anything to the 0 is 1. 3 to the 1 is 3, and 3 to the 2 is 9. So you can see that at 0, we're going, the y value is 1. At 1, the y value is 3. At 2, the y value is 9. And over here, at minus 1, the y value is a third. And at minus 2, the y value is a ninth. So you can see we're getting the pattern I mentioned on the board like this. Looks something like this, and you must state it goes to the point 0, 1. Thank you for listening to this video. I hope you found it useful in your revision for Unit 3.